Math is everywhere, including music, and we have Dr. Pamela Britton from Fields, as well as Sean Elder from MathBeat. And as a nice little introduction here, Dr. Pamela Britton and Sean Elder are two innovative leaders in math education who bring unique perspectives on how math connects with the world around us, including music. Dr. Pamela Britton is an academic coordinator for K-12 at the Fields Institute, an Ontario certified teacher, and a scholar with a master's in mathematics and a PhD in math education. Beyond her academic expertise, Pamela has a passion for music, playing both the trumpet and guitar. I play guitar too, so I'm also excited. And she uses her diverse talents to make math more engaging for students. Joining her is Sean Elder, the Executive Director of Learning through the Arts at the Royal Conservatory and the creator of MathBeat, a program that uses rhythm and music to teach math concepts. And his background as a music composer informs his work in helping students visualize and understand math through their natural skills in counting and rhythm. Together, they'll explore how math is everywhere from the classroom to the world of music and share practical tools like MathBeat and upcoming initiatives like Math Chats for educators. Please give a warm welcome to Pamela and Sean. And I will relinquish my sharing so that Pam can take over.
Perfect. Thank you. That was a lovely introduction. So good morning, everyone. Unfortunately, Sean's been a little held up. He might join us partway through. But we really appreciate the opportunity to present a little bit about the project that we're working on right now to kind of use music to help explore various math concepts and kind of make it come a little more alive. Uh, as a lovely introduction there. So yeah, just a little bit. You heard a little bit about both myself and Sean. It was actually at an OAME conference that Sean was presenting at about the Math Beat that I was attending, and I was very intrigued with how they were kind of uh, putting together mathematics and music using this really innovative kind of app. And I reached out to them and was basically, I said to them, like, is there ways that Fields can work with you? We're a math institute and we're really interested in kind of what you're doing and is there ways that we can collaborate? So over the past few months, that's exactly what we've been doing. So, Math is Everywhere is the program that we've basically started putting together where we're looking at trying to find mathematics in the world around us, using music as kind of a starting point or a jump off or a bridging point, and building on it from there. And also looking at, how does math connect with kind of the world around us and really using some of the innate pathways that we all have. And music is one of those where people are it's a very innate skill with people. We find that when people listen to music, they kind of automatically do things like start counting, even if it's subconsciously, or you're tapping your feet along and you're looking for the patterns. So it's a really natural kind of bridge between kind of two different concepts. And it allows us to tap into things like the visual and the auditory pathways of our students to help them really build a mathematical understanding using something that they all already kind of gravitate towards. You ask any student, do you like music? And they will all find a type of music that they enjoy. So it really is something that is kind of inherent in all of our students and in all of us as well. And then we can use that to start linking it to other real world applications. So what we kind of wanted to or wanted to show was one way that we could use this MathBeat app to explore a concept that many students and many adults as well really struggle with. Um, And that is actually division with fractions. So kind of um, the mathematical explanation that we would give to students is things like telling them multiplication and division are inverses. More multiplication is finding the total when we bring groups of the same size together. Division is asking how many of those groups do we need. So we can do many different ways to explore this concept. So if we looked at something like 15 divided by 3, we can think of it as how many groups of 3 do we need in order to get from 0 to 15? We can also think of it if we have a group from 0 to 15, how can we break it out into groups of 3 and how many of those groups do we have? We can also use it to show the concept of remainders. So if we had 16 divided by 3, we can do the same thing and show that we have 5 full groups and kind of this one extra piece kind of sitting off on the side, which gives us, 5 remainder 1. Or we can also use it to look at how division and fractions are related. So there's kind of these visualization tools that are very common that we use in terms of explaining this. The main one we use when we're dividing by fractions is we teach students the rule invert and multiply. Um, for those who attended the CMS meeting, our plenary speaker spoke about basically the concept of raveling and how when we present concepts to students, we're really focusing on how much innate knowledge do they have in various concepts and or sorry, not innate, how much background information they have in various concepts. And the invert and multiply actually requires students to have a lot of pre-existing knowledge. So if we did something like 1/8 divided by 1/4, we say invert the second one, which turns 1/4 into 4/1, and then change the division to multiplication. And then we can multiply through to find that it's 1/2. But this requires them to know, first of all, you have to invert the second one, that 1/4 turns into 4/1, that whole numbers can be written as fractions as long as they're over 1, how to simplify. So there's a lot of concepts that the students already have to know in order to apply the invert and multiply. Again, we can look at this as a visualization. So we could look at it from if you have to go from 0 to 1/8, how many pieces of 1/4 do you need? And we can visualize that we need 1/2 of a quarter in order to get there. Um, Here's some other examples as well, where we can use visualizations to look at division and division by fractions and why we can divide by something and get a bigger number. This one throws a lot of students. How can you take 5, divide it by a half, and end up with 10? Like, how can you take something and divide it and end up with something bigger? Because normally when division is introduced, we kind of teach it that we're taking a bigger number and we're dividing it into littler parts. So this type of concept really can throw students. Um, so this is kind of it's a tricky concept for students to learn and to understand. And like I say, we do have visualizations and those types of things. But when we start getting into more complex um, examples, say 3/16 divided by 4/16, and you'll see why I've chosen this fraction in just a minute. We do the invert and multiply. So this is the mathematical kind of viewpoint of it. This is the visualization that we can use for it to kind of show how it breaks up. And we can also do things like show students why division is non-commutative. So we end up, if we switch our two numbers, we end up with a different answer. And again, we can have a visualization that can show this, but we really wanted to see if there were ways that we could um, kind of show this type of a concept with a little bit more engagement rather than just kind of here's a rule that you kind of memorize and follow, and you have to remember all these little bits and pieces of it. Or here's a visualization you can draw out, and that's where the MathBeat app comes in, and that's where the mathematics, or sorry, the music portion comes in. So Sean graciously put together this lovely little video that we're going to show where we can use MathBeat to investigate this same topic. And hopefully the sound comes through.
Dividing fractions. Listen to these musical patterns. Pay attention to how the amount of time between notes changes. What changes in the note spacing did you hear or see? The music has different layers, and for this lesson we want to drill down on how the synth notes talk to or fit with the hi-hat notes, as in this example. The synth note and the time between hi-hat notes can both be thought of as fractions of the circle as a whole. The purple note on the outside lasts for 4 of the 16 spaces in the circle, so it makes a fraction of 4/16 or 1/4. The open hi-hat on the inside is separated from the next open hi-hat note by 3 spaces out of 16 or 3/16. We want to know how much of the purple note fits into the space between the 2 hi-hat notes. So we want to know what 3/16 divided by 4/16, or 1/4, gives us. The purple note lasts for 4 spaces, whereas the gap between hi-hat notes is just 3 spaces. So 3 of the 4 spaces in the purple note fit in the smaller interval between hi-hat notes. So now we know that 3/16 divided by 1/4 equals 3/4. What if we did it the other way around and asked how much of the hi-hat interval fit into the longer synth note? In other words, what would we get if we divided 4/16 or 1/4 by 3/16? There are 3 spaces in the interval between hi-hat notes, but to fill the synth note, we'd need a 4th. 3 out of 3 plus a remainder of 1/3 equals 4/3. So we know that 4/16 or 1/4 divided by 3/16 equals 4/3. Now let's take what we've learned and apply it to the second change in our piece. We want to know how much of the 3 spaces between hi-hat notes fits into the 2 spaces of the first synth note. So we want to know what 2/16 or 1/8 divided by 3/16 is. There are 3 spaces between the hi-hat notes, and of those 3, only the first 2 fit within the first synth note. So 2 of the 3 spaces in the hi-hat fit into the synth note. So 1/8 divided by 3/16 equals 2/3. Can you work out what would happen if we did it the other way around and divided 1/8 into 3/16? Now it's time to apply what you've learned by making your own pattern. Go to this URL to access the web app. Enter a different sized synth note and layer it over a different hi-hat interval. Then divide the larger into the smaller note fraction. To enter a rhythm note, click at the left to choose the instrument, then click where you want to place the note. Clicking that note several times will delete it. Click Synth, then the space where you want a synth note. Clicking it more than once will make it longer, and you can scroll it up or down. Press the triangle in the center of the circle to play or stop, and remember to save your patterns. We learned that dividing one fraction by a second fraction is the same as thinking about how much of the second fraction fits into the first fraction.
So that's basically a kind of a mini example of one of the lessons that we could do within MathBeat and how it connects to the concept of dividing by fractions. So one of the things that we're really interested in is that students are often taught procedures for math outside of the context, but the context really makes it relevant. And as I mentioned, music is very much an innate kind of skill for most people, so it helps them to stick. And I don't know how many of you, with either the introduction or with um, the the beats that were shown in the video, were kind of bobbing along or doing kind of that counting in your head, maybe even subconsciously, of when we hear beats and that type of thing. So the other thing that it really shows is you can take that number line kind of example that I had shown and you can wrap it around that circle. And that makes a huge difference as well. So we have one more video, and I noticed that Sean is here too. So we'll show this one, and then I'll give him a chance to join in as well.
Listen to this short musical experiment. At first, the pattern has us a bit on edge. We don't know quite what's coming next. But once the short notes are added, we can count the exact time from note to note. It all starts to make sense. Of course, we don't consciously count it out. Our brain does it for us. And listening to music is what encodes this ability. Students have listened to hundreds, even thousands of hours of music. They all have this ability to count music. To tap into this capacity in math class, we needed a math-friendly music visualization. A number line conveys linear time, but misses out on the circular aspect of repeated musical ideas. So we wrapped a number line around a circle and then divided the circle into 4 equal fractions called beats. So this looks like this. We've created dozens of lessons featuring connections from music to basic operations and proportional reasoning. Students discover that math is everywhere, including in the music in their heads. Check it out at mathbeat.ca.
Perfect. So basically just in terms of next steps, we're looking at doing things like math chats, in-class or virtual presentations, and online courses and resources for teachers. We're working right now at putting together some basically lessons that link kind of the way that teachers and whatnot are familiar with in terms of these things with using MathBeat as well. And we love some feedback and discussion. So Sean, anything that I missed, anything you'd like to add?
Pam, you really covered it extremely well. I just want to add one thing, is why we got into doing this is because we worked really closely with thousands of teachers over the years with our program, Learning Through the Arts at the Royal Conservatory, which basically paired different artists with classroom teachers to tackle common problems faced by students. And really, I guess what this showed us and convinced us was that the current methods that teachers were using were leaving too many kids behind. And, we got that statement directly from students saying things like exactly what Pam was highlighting, saying things like, well, you're going too fast. You're jumping ahead. You're leaving me behind. I don't understand this word. I don't understand what you're referring to. You're just asking me to memorize something. And you could see by grade 4, 5, 6 a progression. By grade 6, kids' backs were up so far. So many of them were now just so far behind in terms of their grasp of the language, of the ideas, of the concepts. And then also, as Pam mentioned, we got pointed towards the area of proportional reasoning, because clearly that's the kind of big transition where you have kids thinking about absolute quantity for a long time. Multiplying two things together gives you something bigger, right? And then all of a sudden we're telling them, oh, hold on a second. You multiply two things together, you get something smaller, and it just freaks them out. They don't get a lot of time on it. And it's kind of a jump that I don't think you can just make by reaching back to prior knowledge. And I believe this is where MathBeat can be most useful, is where kids need additional context. I mentioned to Pam that I read a very interesting article about the philosopher Wittgenstein, who in an early stage of his career taught children in elementary and discovered what great challenges they had in learning certain words and the meaning of them. And he realized that the kinds of dictionaries that were available were not suitable for children. And to the process of actually assembling a sophisticated concept out of the blue, which you couldn't just relate directly to prior knowledge. And I think this is the example we've shown today is an example where we're trying to get at what is the core thing here that's going on in some tangible way that kids can relate to. In this case, the prior knowledge is music and just their familiarity with listening to music, but it's still a big leap. And we're not saying that MathBeat is going to, reach every student, but we believe that it's going to reach enough, and it's specifically going to help those that have struggled and have started to turn off against math because of the fact that teachers frankly don't listen to them and progress and have to go forward at a certain pace to meet the curriculum and so on. Yeah, that's great. you've lost a lot of kids along the way. And so what we're trying to do is just put something in the mix that can maybe salvage the math future for that significant asset reserve of maybe 1 in 4 kids in the classroom that are just lost. They are completely at sea. So that's what's the context around this.
I know that we have very limited time because we have to move on to the next presentation. But I'll ask our presenters, do we have time for 1 or 2 questions or?
Yeah, actually, thank you, Pam, and thank you, Sean. We're going to sort of save the questions from the participants, but I'm going to ask you a question. I'm going to put both of you on the spot. I hope it's okay. Paul and I have a question. We have a few questions, but we're going to narrow down to one right now. And this is to both of you. So first off, thank you for that wonderful summary. And I did attend the session at CMS. So here's a question for you. What advice would you give educators who are new to integrating creative disciplines like music into their math teaching practices based on the experience that you've had so far?
Sean, do you want to
Yeah,
go first?
maybe I could jump in first. You've hit on the core question that I think affects the relationship that teachers bring to something like MathBeat. And, I think the great challenge we're up against is when we started this work 25, 30 years ago, we actually brought an outside specialist into the classroom to work with a teacher. And that is a formula that teachers were more comfortable with, in the sense that teachers felt like, yeah, I don't know anything about music, so if I'm going to use music, I get it. Music's got math in it, and it's a valuable connection for students in terms of building their understanding. But I'm not an expert in that subject area. So what we tried to focus on with MathBeat that's different is it's based on listening. And it's just listening. You don't have to have any musical training to benefit. And the reason why is because of the brain's quite sophisticated skill at following music. And if you've read neuroscience about music at all, or even come across some of those ideas, it's clear that the capacity to listen and follow music and memorize a song, which almost every student by grade 4 has to a very high degree, they can instantly identify different songs apart and that sort of thing, is probably their most significant cognitive asset at that age. It is the most developed cognitive asset that they possess, and it's just listening. But we undervalue it, because in our culture, it's all about the musician doing the making of the music. All that's seen as the real skill, whereas actually the skill of following and memorizing the music, detecting the patterns and following them and committing them to memory and being able to measure the relationships, just as my little example showed, that it's actually easier to follow a beat if you can hear the subdivisions of the beat. That all of those kinds of things are foundational to us all as humans, as people who listen to music. So no subject area expertise is required. Interestingly, we had a little discussion a week ago where there was a comment, are you trying to teach music through math, or are you trying to teach math through music? I think because some of the participants were people who taught both subjects. So naturally, they're kind of wondering is there an intention here to teach kids music? And so we actually went back and made some slight changes to the video where I had started with a musical concept, and I realized no, that was actually a mistake, and that's probably what triggered that kind of comment. So we're still learning here from teachers as to how we can cut to the chase on this stuff and get it really clear, get it really simple, so that the teacher doesn't have a cognitive barrier to overcome in order to bring this to the student. But it's novel, so we know that with anything novel, we're going to still have the requirement to have experience of it. And our strong suit has always been, if you put this in front of kids, you have to see it to believe it. The degree of engagement that they get from learning this way is so completely powerful. that, it's taken us many, many years, and our motivation has been that we know it works for the student, but we've had to sort of reverse engineer to make it work better for the teacher. And I think finally our relationship with Pam and Fields Institute is really a large part of what we see as the solution, which is let's start where teachers are familiar, like with the kinds of number line examples that she showed. And allow teachers to feel confident that they're bringing their best foot forward to their students with their resources, and then have a jumping off spot, which allows the teacher to say, yeah, I'm going to spend a little bit more time looking at the core concept in a different lens and trying to reach those students that I know are still struggling. That's the way we're hoping that it will knit together. And we also see a lot of advantage here of bringing this to teacher candidates. We didn't mention that, but that's something that we'd really like to do as well, so that this gets entered into the framework of what teachers bring to the classroom from the very beginning, rather than, we know that once teachers are there and they've had several years under their belt, they may not be as open to new approaches. So it may be that for this to really achieve its potential, there's a generational component to it.
That's great. Well, thank you so much, Sean and Pam. We're going to come back a little bit later, but I love what you said there about the listening. How often as teachers do we not take the time to listen? And that's a great endpoint there.